Do you have an ESP32 and you're trying to figure out how to write code for the Bluetooth low energy stuff? Maybe you're scratching your head a little bit when you look at the examples that come in the Arduino IDE and you're like, man, I'm just not sure what's going on here. Well, if that's you, what we're going to do in this video, what I'm going to try to do as best as I can, is we are going to go line by line and write code, and we're going to start by making a BLE server. We're going to talk about every single line of code. I'm going to try to make it as simple and straightforward as possible. So if that's what you're up for, stay along for the ride. Now, I need to be clear what this video is not going to be about. I'm not going to be talking like generally about general stuff about BLE, right? I'm not going to tell you about, the frequency it operates at and like what it's best used for and all that. None of that stuff. We're just going to talk about the code. I want you to like practically be able to write code for a BLE server. Now we will be talking about the GATT, because you can't get away from that if you're working with BLE, but that'll actually be more informative than anything. All right, let's go for this. All right, so here I am in the Arduino IDE, and I just want to highlight something. All right, so I'm using an ESP32 dev module, like El Cheapo ESP32 from China. You know what I mean? Some dev board. I think it's like the Vroom. Okay, I'll leave a link in the description if you want to, get the same one. So I've got that board selected in the Arduino IDE. And when I come up to File and I go down to Examples, you can see that some examples come installed for this board. And there's two sets of examples. There's BLE and then there's Bluetooth serial. So what's really important to understand is that Bluetooth comes in two different flavors. You've got Bluetooth Classic, which is kind of what a lot of people think Bluetooth is, which honestly, I kind of thought Bluetooth was kind of like the big deal, which is, when you connect your phone to like some wireless speaker or something like that and you're streaming audio, like that kind of thing, right? So Bluetooth Classic is what we are not going to be talking about in this tutorial. What we're going to be talking about is something way more fun. It's called Bluetooth Low Energy, BLE. Bluetooth Low Energy is way cooler. It's for just sharing small amounts of information between different devices. So for example, I've got an electric toothbrush and it's got this little clock that comes with it. And when I start the toothbrush, it does this countdown on the clock, like they're talking to each other via BLE. Now, okay, brushing your teeth, you couldn't get more boring than that, but still, you can do all types of interesting stuff. You'll notice that the library comes with a lot of BLE example code, and I highly recommend you check these out. We're going to be working on building a server, but we're not going to use their examples. We're just going to write from scratch. Okay, so before we dive into the code, though, we need to talk about the GATT. It's the generic attribution profile. And I just think of like Gatling gun, because when I try to wrap my head around it, I feel like somebody just shot me with a Gatling gun. So what is this whole deal exactly? Like, what's going on? Well, this is just a way for us to think about the different layers of the BLE protocol. So notice that these are all nested, all right? And I want you to think of the top level as the server. And you can kind of think as the server as like a widget, like an actual device. Like, for example, my toothbrush, right? So we could say, hey, the toothbrush is a device, right? But that device is running a server. We can also call that a peripheral, all right? So we've got our toothbrush. Now, the toothbrush, it can have one or more services associated with it. So maybe one of the services it has is like user data, and maybe it has another service that talks about like power consumption or something like that. And each service has this thing called a UUID associated with it, which is a universally unique ID. I kind of like that acronym. I think it's a little silly, but whatever. Now each service can have multiple characteristics associated with it. And the characteristic is the actual value, right? So let's say that this was the user data service for my toothbrush. And let's say that the characteristic here is like time running, something like that. And so the value would be, I don't know, how many seconds it's been running since it, last started. Notice that the characteristic also has a UUID. And since service and characteristic weren't enough, we can also have descriptors, and a descriptor is assigned to a characteristic. So a characteristic can actually have one or more descriptors. It doesn't have to have any, but it can have a bunch. And what the descriptors do is they add metadata to the characteristic. For example, maybe it'd be like time in milliseconds, right? This would be like, oh, hey, that value is meant to be milliseconds, something like that. Or if it was a temperature, Fahrenheit or Celsius, that kind of thing. Notice that the descriptor also has a UUID. Okay, again, so this is the generic attribute profile, and every piece we code, you're going to see these words: server, service, characteristic, description, descriptor. I just want you to get this stuck in your brain. Okay, now before, just real quick, I said that, right, here's a server. It could have multiple services, see, like that. And notice that this service right here has two characteristics. This characteristic doesn't have any descriptors. This one has two descriptors. You kind of get the idea, right? So we can get all crazy here. But this is a slide I really want to show you because there's just a lot of complexity that we're going to get into, right? And I'm not going to be able to talk about all of this stuff in this video. Maybe in upcoming videos we will. Now here's the deal. BLE has a lot going on. In fact, part of the reason it's so cool is because there is a lot going on, but it just takes a while to like start figuring out what all this stuff is. All right. So this diagram here, I don't want you to like it's like makes me want to barf my brain out when I look at this a little bit, but this doesn't even get into all the details by any stretch, but it just kind of diagrams out a little of the stuff that you can do. All right. So basically at the heart of this ESP32 BLE library is we have this thing called a device, and you can tell your device, hey, let's be a server, or you can be like, no, you know what, let's be a client. And then a device can do things. It can also do a scan looking for other BLE stuff, right? But let's say you're a server, because that's what we're going to be working on today. We're going to write our own server. Now the server can do a couple things. Notice it can advertise, and it can also notify. Now we're not going to be talking about notify today. Maybe we'll talk about it at some point, but we're just going to be talking about the advertising today. You'll also notice that a client can connect to a server. And again, the idea is like an information exchange, right? So a client can write to a server, client can read from a server, like we can exchange information. Now, the way the ESP32 library works is all of this stuff is basically encapsulated in different classes. So let's check this out. Now, this is just like that previous slide. I just took some of the stuff out to make it hopefully a little more readable. But basically, you can see the idea of a server is encapsulated in the BLE Server class. And then we've got a BLE Service class, a BLE Characteristic class, we've got a BLE Scan class. Let's just say there's a lot of classes in this ESP32 BLE library. All right, well, that was enough of stuff that's not writing code. Let's go ahead and get into the code writing. First thing I'm going to do is write out a to-do list, and then we'll talk about it. So let me do that. JLC PCB provides easy, affordable, and reliable PCB and PCBA solutions, empowering electronics engineers to develop projects efficiently. There's easy ordering. Order PCBs from JLC PCB effortlessly. Upload your Gerber file to get an instant quote and order in minutes. It's as easy as shopping online. Get 1 to 8 layer PCBs for just $2. Efficient, large-scale production, reducing costs, and bringing you unbeatable prices. Plus, the quality and lead time is reliable. All in-house production, ensuring quality stability and strict quality control in every process. Plus, rapid turnaround, lightning-fast PCB production in just 24 hours. Don't miss JLC PCB's 6-layer PCB special. Get $30 off with a coupon and enjoy top quality 6-layer PCBs, plus no engineering fees for VIA in pad. Oh man, this is a lot of stuff, isn't it? I'm telling you, this Bluetooth low energy stuff, it's super cool, but there's kind of a lot to go over. So I'll try to keep this quick. All right. Well, first thing we're going to do is we are going to create a BLE device. All right, so we'll do some things associated with that. Then what we're going to do is we're going to say, hey device, we want you to be a server. So we're going to make ourselves a server. So let's look back at our GATT example. Remember, we've got a server, and then, or rather, we've got a device, and a device can be a server. Well, we're going to say, hey, be a server. Okay, then what we're going to do is we are going to make some server callbacks. And this part right here is probably the most confusing part of this whole ordeal, because the callback syntax is it just looks a little weird if you're not used to seeing it. But once you wrap your head around it, I think you'll be on your road. This library uses lots of callbacks using the same syntax. I'm going to show you how to do that. Hopefully we can figure that out. All right, then what we're going to do is create a service, and we're going to attach it to that server. We're going to create a characteristic. We're going to attach it to the service, and then we're going to make some callbacks for our characteristic. We're also going to be taking a descriptor. We'll make a descriptor and add that to our characteristic. All the while, we are going to do some advertising. We're going to advertise the service. Now, I'm probably going to keep all this in the same order here. We might jump out of order a little bit, but just again, looking at this GATT chart, right? We're going to make our server. We're going to assign a service to it. We're going to assign a characteristic to that service, and then we're going to assign a descriptor to that characteristic. And then at some point, our server is going to be advertising its information so that we can pick it up. Okay. So let's go ahead. What I'm going to do is first I am going to write some code for this BLE device. Let me do that, and then we'll talk about it. All right, so what I did is include the BLE Device.h header file. So I'm just including this BLE library. Now what's cool about this library is it comes pre-installed with your Arduino IDE when you add the ESP32 Arduino core. So I won't talk about that. Maybe in the description I'll link to, if you haven't installed the core. You probably have already done that by now if you're working with ESP32 BLE. But anyway, this comes pre-installed. So I included this library. The next thing I do is I define a device name. So I'm just giving it something silly, like CIA monitoring device. This is what I want to show up when I scan for this device. Now we're going to be using a phone application called Light Blue. It's available in iOS and an Android. I stinking love this app for kind of like troubleshooting your BLE, kind of getting stuff set up with the ESP32. I think it's super user friendly. It's free to download and use, so that's what we'll be using. But when I open that up, I want to be able to see CIA monitoring device as one of the listed BLE items. All right, so that's the device name. Now, I just called this device name. Like, this is just to define. I don't have to call it device name. I could have called it device signature or device ID, whatever. Like, we're just making that up, right? So I just made that up and I made this up. Okay. Then down in the setup function, I start serial communication. I like to just put a little print in for, troubleshooting as I'm going along, just to make sure, hey, setup is actually starting. And then I do this thing right here, which looks kind of weird. All right, what's going on here? So we're saying BLE device. This is a reference to the BLE device library, which we just included. But then we've got : init, and then we're passing in device name. All right, so maybe you've worked with libraries in the past with Arduino, right? And you might be used to something like this, where you've got like serial.begin, right? Why isn't this BLE device.init? Well, what's going on here? And I won't go too in depth on this, but the init function is a static function part of this BLE device class. Okay, so the BLE device is a class in like C++. Init is a static function. So what's going on here is that the creators of this library only wanted you to have one instance of this BLE device actually made. So with like the servo library, you could say like servo number 1 and servo number 2 and servo number 3. You could make a bunch of instances of the servo class, right? You can make a bunch of different servo objects. That is not the case for the BLE device library. You can't in one program, make a bunch of different devices. There's only one device, and this init function starts the entire BLE stack that your server is going to depend on, the advertisements are going to depend on, everything kind of starts with this init. But you only do it once, and kind of that's why that's funky looking. Hopefully that makes a little sense. Yeah, a little bit of hand waving there, but that's what's going on. You're going to see this colon syntax quite a bit because this library uses a lot of static functions. Okay, so we did that. Let's go see what we can check off of our to-do list. All right, so we imported the BLE device library. Check. Gave it a device name. Awesome. Initialized it. All right, hey, we are moving it along. We have created a BLE device. Man, I'm feeling good. All right, the next thing we're going to do is go ahead and create a server. So let me write some code and then we'll talk about it. Okay, so what have we done now? So here, we're down here in the setup. We, started serial communication. We initialized the device, and now we're creating the server. Now, oh man, you might be like, Mama, what is this? All right, yeah, okay. So let's talk about this. If you are not comfortable with C pointers, then you're going to be a little uncomfortable during this presentation because we're going to use lots of pointers. Now, I won't try to, tell you right now in the next couple minutes what pointers are. But if you do want to learn in depth what pointers are, check out our training program. We've got a whole course that dives in how to understand pointers. They're really not as confusing as you might think, but they're just really a big part of C that they're pretty helpful. Anyway, a pointer is simply a variable that holds the address of another variable. That's literally all it is, all right? The address in memory, right? And so what's going on here, all right, is we're making a variable. It's a pointer, okay? And we're just giving it a name, P server. We could call this anything we wanted. By convention, when you make a pointer, a lot of folks stick a P in front of it so people know, hey, it's a pointer. I like this convention. That's, why I'm following it here. Okay, so we could have named this anything. We're calling it P server. All right, it is a pointer. It is going to hold the address of another variable. Well, what is this other variable it's going to hold? Well, it is going to hold a server. So it's going to hold basically the address of a server, and that server is getting created by this BLE device that we initialized back here. So we've got BLE device, and notice we've got our colon syntax again. So this is a static function that's part of this BLE device library. All right. You can kind of think of it as like, I don't know, almost like the setup of the class a little bit, right? I don't know how to say it, right? But anyway, it's a function that we're able to call, a static function we're able to call, and it's going to return us a server object, all right? And that is going to return us a address, a reference to it, right? And that's what's getting saved in P server in this variable right here. And the type, this type here is just a BLE server. So this is a type in the library, okay? And this BLE server right here is just the name of the class that this is a reference to, all right? So what type of pointer is this for? Well, hey, it's for a BLE server type of pointer, right? I don't know if I'm saying that quite right, but this would, like, let's say we were making an integer, right? Let's say we were making a pointer to an integer. Well, it would be an integer pointer. Well, this is a BLE server pointer. It's just BLE server happens to be a class that we're pointing to. Okay, hopefully that made a little bit of sense. But what do we have now? Well, what we have now is we have this thing called P server that is our server. So this P server is what we'll be adding our services to. And when we add services, then we'll add characteristics to our characteristic. Okay, so hopefully that makes a little sense. Let's go ahead and go up here, see what we can check off here. Okay, so I created the BLE server, but I want to tell you a little trick here. Notice I did not import the BLE server library. Why didn't I do that? I mean, we're using BLE server. Wouldn't I need to import the library? Well, check this out. In a lot of the examples, they do include, they include like BLE device, BLE server, BLE this and that. But if you go into the BLE device library, you just go to the definition here. So here's the code that's in BLE device.h, right? They already include BLE server, BLE client, BLE U2s, BLE scan, BLE. They already include all these. So why? I'm not going to double include it. It's already got it. Like, it's just more lines of code to write. So we didn't even have to do that. Man, that makes me feel good when I can skip something. All right, so we've created our BLE device. we've created the server. Now what we're going to do is create some server callbacks. All right, if you thought what we did so far was weird, wait for this. All right, let's do this. We'll write some code and then talk about it. All right, so I wrote a little bit of code. We're going to talk about this. All right, let me just do a quick review what we've done before we talk about the new code. We had our includes, right? We included the BLE device library. We gave our device a name that we came up with called CA monitoring device. We started some serial communication. We initialized the device using that static function in the BLE device library, right? We fed in the name. And then we made our server, right? So we created a server. And now what we're doing is we are creating callback functions for our server. Okay, so let's go ahead and take a look. So here's setup down here. This callback function is above setup. In fact, it's not a function. It's not just a function. It's a class. Now that's weird. So let's first talk about, well, what the heck is a callback? All right. Well, a callback, generally speaking, is a function that is going to get executed when something else in your code happens, right? In this case, the server has two callback functions. One is onConnect and one is onDisconnect. So basically what this means is anytime a client connects to our server, this function right here, onConnect, it's going to get executed. It's going to get called back, right? Same thing here for this disconnect. If a client disconnects from our server, this function is going to get called. And by setting these callback functions up like we set them up ahead of time, right? We don't have to like write in the code. We don't have to say somewhere in the code like, hey, when the server disconnects, do this. Like, we don't have to manage that. The BLE stack takes care of that. And when I say BLE stack, what I'm basically saying is this BLE library is going to handle all this stuff for us, right? So when a client connects behind the scenes, it's going to call this function for us. When a client disconnects behind the scenes, it's going to call this disconnect function. Okay, so what's the deal with this? Like, why are we writing a class? Why do we, and these functions in here? What's the deal here? Okay, well, let me try to explain this as best I can. Basically, this BLE server callbacks, this is a virtual function in C++, all right? And it's meant to be overwritten. Okay, so what we're doing is we're making a class that is a subclass of this BLE server callbacks, all right? And so that's what this whole thing right here, this colon right here means, all right? So we're writing a class, it's called my server callbacks. It is a subclass of BLE server callbacks, all right? Let me go, if I can go ahead and take a look at the code here. There we go. Okay, so check this out. Now, I know there's like a lot going on here, but basically, notice all it's got here is void onConnect and then some parameters with it, right? So like a function signature, and then it's got void onDisconnect, another function signature. So what we have to do is they kind of provide us, I'll call them the handles, right? They provide us the function signatures we need to use inside our subclass. So we have to use onConnect, like this literal exact verbiage with these parameters, right? A BLE server, a pointer to a BLE server. And we have to use the function onDisconnect, again, with the same parameters here. But on the inside of this function, we can write whatever gibberish we want. So I don't know if that made any sense to you or not. I don't know. It's kind of hard to explain, but basically we are subclassing this BLE server callbacks. And this isn't anything like special I'm coming up with, right? This is all in the example code with this library. Like this was the, this is the idea, is that you subclass these callback classes and then, overwrite the functions in there, and then you can give the functionality you want. So this little paradigm right here, this, syntax that we see right here, you're going to see this over and over again in this library because almost every object has some callbacks associated with it. So what I'm talking about here is remember our setup right here? So we're going to have server callbacks, we have service callbacks, we have characteristic callbacks, we've got, like client callbacks, I think there's scan callbacks, there's callbacks for everything. And so basically the only thing that changes is that like the name of the callback will change, right? And then the functions on the inside, like the handles you call them by, the signature is going to change. It might be like on result or something like that. And, we'll be talking about some of those in this lesson and upcoming lessons. Anyway, okay, then just to be clear, see this word right here? This is under our control. We're allowed to give this class whatever name we want it. Now, in the examples, they use my server callbacks, right? Now, I actually can't stand the name my server callbacks. It reminds me of like my documents. Like, come on, give me a break. But I could not think of a better name. When you put the my in front of it, now like you don't confuse like server callbacks with BLE server callbacks. So anyway, I'm sticking with this my server callbacks. You could call it like whatever you wanted. Like I said, I couldn't come up with a better name, so I'm sticking with this my server callbacks. All right. Okay, so what are we actually doing? So here's what I want to have happen. On the ESP32 that I'm using, there is an LED on digital pin 2. So when a client connects, I want to turn that pin on, and then I'm just going to print something to the serial monitor. And if a client disconnects, I'm going to turn that pin off, and say the client disconnected. Okay, so that's how you make this callback. All right, now I talked about this at length because when we do other callbacks, I'm not going to talk about them as much. So if you're still wondering about this whole thing, just kind of come back to this part here. So now that we've created our callbacks, now what we need to do is actually assign them to the server. We have to set those callbacks. All right, and we've got some more, kind of weird syntax if you're not used to pointers. All right, so if you recall, pserver is a pointer for our server object, all right? Now, our server object has some functions associated with it. And normally, right, when you're using functions that are part of an object, you'd use this like, dot operator, right? So serial dot begin, right? We're accessing this begin function from the serial library. So I use this dot. Well, when you have an object that's a pointer, you can't use that dot operator. You actually need to use this little arrow, right? So it's the same thing, like there's a set callbacks function that this pserver has, but since it's a pointer, we can't use the dot operator. We have to use this little arrow syntax. So we're saying, hey, we want to use this function from this pserver class, set callbacks, and now what we do is we pass in our my server callbacks function. Right, so this was the name that we gave our callbacks class up again. Remember my server callbacks, and then you've got the new keyword in front of it. I know, looks a little crazy, but again, this line of code is going to repeat itself, several times as you work with this BLE library. The only thing that changes is whether it's callbacks for, a server or characteristic, whatever. Now I added one additional thing here is I went ahead and started advertising. Notice that this is another static function from the BLE device library, right? And the reason I wanted to start advertising is once we do this, now when something scans for BLE devices like this phone app, this light blue phone app we'll be using, it will be able to show up some information. And the only information that we've really got available right now that we've specified is our device name, which is what we specified when we initialized our BLE device. So what I want to do is go ahead, let's take a look at the phone app, and we'll take a look at the ESP32 and see how this is working. All right, so here's my phone app. This feels really personal, showing you my phone and all. Anyway, okay, so here's this light blue app. Again, this is the app I recommend doing. I mean, there's all types of apps that do this. I really like this light blue one, though, I got to say. Okay, so I'm going to open this up. And what it's going to do is it's just going to scan for BLE devices in the neighborhood, all right? So we can see we've got, my printer, some unnamed device, some random mesh device, Michael's iMac. Okay, hey, bam, there we go. Now look at this, CIA monitoring device down here. Okay, see at the very bottom? Hey, that's pretty interesting. I'm just gonna hit this arrow. What do we see here? Okay, so, it gives a local name. It says CIA monitoring device. It tells me a transmit value. There's really not much I'm learning from this though. I'm gonna go ahead and click connect. Okay, so now I've connected to this device, and you'll notice that the LED on my ESP32 turned on. Like, that's pretty sweet, right? Because that was that my server callback class, right? Like the callback on connect got called, that LED turned on. Now, again, we don't really have any advertisement data in here, right? We haven't specified anything yet. This is all part of what we'll be doing when we start adding services and that kind of stuff. Okay, now what I'm going to do is I'm going to go ahead and click these 3 buttons up here at the top, and I'm going to disconnect. Now, when I disconnect, notice that that LED turned off, but I want to show you something that you wouldn't have thought of. All right, so now I'm going to refresh my screen, right? So we connected and we unconnected. Now I want you to notice that, wait a second, where's my device? Like it's not showing up anymore. Hey, what gives? Like, what is my ESP32 broken? What's going on? Well, here's the deal. What happens when your device gets connected to and then disconnected is that the advertising that we started, it automatically stops. So as soon as a client connects, actually, is when the advertising stops. So if we want to continue to advertise to other devices out there, or to advertise again after, one of the devices disconnects, we need to start the advertising again. So what I'm going to do though, just to show you, I'm going to go ahead and reset. What I did is I just reset my ESP32, and now see how we see it down here at the bottom again. And I'll just go through this one more time. I'm going to connect. I'm going to go up here. I'm going to disconnect. And then when we come back here, we'll see that it disappears. I'm doing like another scan. See, it's not here. And even if I scroll down, I promise you it's not. It doesn't show up. So let's go ahead and go back to the code and see if we can fix this in our server callbacks. It's actually a feature, right, to have it stop advertising. All right, so here I am in the code, and I'm going to come up to our callbacks section right here. I'm in my server callbacks. This is this class, or that we subclassed from the BLE server callbacks. And what I'm going to do is I'm going to say when a client disconnects, that's when we're going to start the advertising. So let me do that. All right, so what I did is I added this one line of code, and I just said BLE device start advertising. Again, that static function of this BLE device library. Same exact line of code that I used down here in setup when we started advertising. Because remember, after a client connects, this advertising stops. So your device, it's not going to be announcing to scanners out there or anybody. It's not going to say like, hey, this is my name and I've got this information, unless you're advertising. Okay, so let's go ahead and jump over to the app and see if that fixes things for us. All right, here I am in the light blue app, and we can see our CIA monitoring device. So I'm going to go ahead and click connect. Okay, my LED came on. That's cool. And I'm connected. Sweet. So now I'm going to hit those 3 dots up there, click disconnect. So the LED goes off. It shows me disconnected. Now let me go back and notice I'm going to refresh. Look at that. See, now CA monitoring device, it shows up again. Because, again, the device before, it wasn't starting advertising again. But now it is once we disconnect. So I'm going to go to connect. All right, I'm connected. That's cool. Again, we don't have any information associated with it yet. We'll be doing that shortly. I disconnect and go back, and there it is again. So this is really cool. Okay, all right. So let's go ahead back into the code, and we'll start adding services and characteristics and that kind of thing. Here we are in the code. Let me just check off what we've done so far. So we did the on connect. Nice. We did the turn on LED. We did the on disconnect, the turn off LED. We've created our server callbacks. All right, yay for us. The also thing we did though is we did start advertising. So that was a little additional thing I thought would be fun to do. Okay, so we've got that done. Great. So the next thing we're going to do is create a service. So I'm going to go ahead and do that, and then we'll talk about it. All right, so what the heck did I just do there? Okay, so let's start with the first thing I did, is I defined a service UUID, or universally unique ID, all right? And this is this big, long number here that I did not make. Instead, I used this link here. It's just a UUID generator, and it generates this random long number. And basically the idea is you use this long number so that the chances of two devices having the same UUID are very unlikely when you use such a long number. Okay, so I just generated this number and I'm calling it the service UUID. Now what the heck is this? Well, here's the deal. Here's what it is. Remember our wonderful GATT chart? Well, according to the BLE specification, every service will have a UUID, every characteristic will have a UUID, and every descriptor will have a UUID. So I have to have a UUID with my service. I can't not have one. It's a requirement in the specification. And that is why we've got one in here. Okay, so now that I've got this service UUID defined, so now we come down to the services section. So what's going on here? Hopefully this looks a little bit familiar, but we're making another pointer. All right, so this is P service, little asterisk says, hey, this is going to be a pointer. Again, a pointer is just a variable that holds the address of another variable. In this case, it's going to be pointing to a BLE service object. Okay, now how do we create this service? Well, we actually ask our server. So remember we made a server up here. We made our server. Now we're using a function from that server class called create services. And if you recall, pserver was also a pointer, and so we have to use that little pointer syntax here when we're working with the pointer. So we're using the create service function from this pservice class, and all we do is pass in our service UUID, our service 1 UUID. And again, I just came up with this name. You could call it whatever you want. Maybe something more descriptive would probably be a good idea. So what this is going to do is this is going to return a reference to our pservice object, and it gets stored, and that's what pservice is going to be pointing to. Okay, so we went ahead and created our server. Now what we do here is we use the start function from this pservice class. And again, pservice is a pointer, which is why we're using that syntax right here. So we've got to start the service. So what does it mean to start the service? Well, let's go ahead and take a look at the phone app and see what's changed. Okay, so here we are in the light blue app on my phone, and we can see the CIA monitoring device that we made. And notice here, nothing seems to have changed here. Let me go ahead and connect. Now my LED turns on. I love that. Now notice under services, look at that. Do you see this big long number? Well, this happens to be the service UUID that we just added. So now we can see that that service address is shown. Okay, cool. So we've added a service, but man, doesn't this still feel a little bit like a bit of a letdown? Because wouldn't you think that a service actually provides something, like it serves something up, right? Well, the part that actually holds the data for your service is the characteristic. So the characteristic is kind of where all the action happens, I guess. So let's go ahead and jump in the code and see what we can do about adding a characteristic. All right, so we got our service up. Let's see if we can check anything off. Okay, so we define the service UUID. We created the service, and then we started the service. All right, that's done. All right, so now what we're going to do is add some meat and potatoes to our service. Basically, we're going to add a characteristic. And not only are we going to add the characteristic, but we're going to add a characteristic callback to our characteristic. And specifically what we'll be doing is every time a client requests information from our server, from this widget we've got right here, what we're going to do is we're going to send them the value of the millis function. So basically we're going to say, hey, we've been running this long in milliseconds. Like, maybe we could have a sensor attached and we say, hey, the temperature is this. But the only time we're ever going to either, read our sensor or send back the time is when somebody asks that, and that somebody is a client, right? And what's awesome about this is, remember, this is Bluetooth low energy. We wouldn't want to continually be, reading a sensor and transmitting the data, reading the sensor, transmitting the data, if nobody's listening. It'd be like a tree that falls in the woods. Does anybody hear? Whatever. It's like we only want to expend energy when it's required. And that's the whole idea with this callback idea. Okay, so I'm going to go ahead and write some code, and then we're going to talk about it. Let's do this. All right, so we wrote a bunch more code. Let's talk about what we did here step by step. So the first thing I did is I added a characteristic UUID. Again, I just used this UUID generator. It's free to use. It's just this little website. It generates this big long number. Why do we need them? Because the BLE specification says you got to use them. So we've got our character UUID defined up here. All right. And then what I did is down in setup, I went ahead and I created a characteristic. Now, see how this is following. First, we make our device. This is like the top level object, kind of the top level thing that's going on. Then we use the device to make a server. Then we use our server to create a service. And now we're using our service to create a characteristic. Do you see how they're all kind of like nested in one another? Okay, so what's going on here? Well, we've got our pointer again, P characteristic. Again, we could name this whatever we wanted. I mean, the P part's the convention for a pointer. Characteristic, maybe you could name it something more that described exactly what it was. That probably wouldn't be a bad idea, but I'm just using the word characteristic right now. Okay, so this is a pointer and it's pointing to a BLE characteristic object, and the reference here is being provided by P service, which is the service that we'd created just a step before, right? And so we're just calling the create characteristic function from that P service object. And now in this case, we've got to pass in a little bit more data in order to create our characteristic. And this looks a little bit different, all right? But let's look at this. See, when we created our service, all we did was pass in the service UUID. Well, here, when we're creating this characteristic, this could all be on one line. I just want you to know that I've got this separated on multiple lines, so it's a little easier to read. But this is just taking two parameters. The first, it needs to know the UUID. So that's what we've got right here. This was that big long number. Here's the UUID. Do you want to supercharge what you know about Arduino? Start writing your own code instead of just cutting and pasting? Definitely check out programmingelectronics.com. We have a training program that's been designed to get you up to speed fast, writing your own code and building your own projects with Arduino. Check it out in the link below. That's programmingelectronics.com, and check out our training program there. This next line is it's kind of weird. All right, so basically, what we need to pass in, what this create characteristic function expects, is it wants the UUID and then it wants some properties. So our characteristics that we add to a service, which are part of a server, our characteristics have these properties, all right? Well, what properties are they? Well, there's like a read property, there's a write property, there's a notify property. And the way we set those properties is by adjusting these like bit flags inside the library, all right? So we would change one of the bits to a 1 if we want it to read. We'd change another one to 1 if we want it to write, right? So it's a different bit, okay? And so what this is doing is it's doing an OR operation on two different properties. And so this property read is literally just the value 1, all right? This property write is literally the value 2. When we OR them together, we get a 3, but it's setting like a bit flag on different bits so that we say, hey, we want this to read and we want this to have the write property, all right? Now, this syntax is a little bit weird, but basically we've got our BLE characteristic class, okay? And property read is just a constant inside that class. In fact, if we dig into this, I'll just go to definition. So here's this, we're in BLE characteristic.h. So here's this class written out right here, okay? And if we come down, we can see that there's these static constants right here, okay? And they're specifying like which bit we're going to change, okay? And notice that we've got read, write, notify, broadcast, and so we just selected the read and the write. Okay, probably is about as clear as mud, but hey, that's how we make our characteristic, okay? So you want to say, hey, can we read the characteristic? Yeah, we want to be able to read it. Can you write to the characteristic? You might want to. In our case, I said that we're going to be returning the time. It really doesn't make sense for them to write the time. That doesn't make a lot of sense. I'm just including it for, I don't know, kicks. Okay, so anyway, we've got this here. All right, so I've created the characteristic, and then what I do is I set some callbacks for my characteristic. So we're calling the set callbacks function from this P characteristic object. All right, and here is the reference that I'm making to my characteristic callbacks. Let's talk about these callbacks real quick here. All right, so here is my subclass BLE characteristic callbacks. Again, I've called it my characteristic callbacks, and I am overwriting the onRead function, right? And so I had to follow this exact function signature right here. So I had to call it onRead, and the parameter needed to be a pointer to a BLE characteristic. Okay, so that was a requirement. But on the inside, I can do whatever I want. Now, what's neat about this onRead callback is when it's called. So let's go back to our little chart here. Okay, so we've got our client, we've got our server. Let's say the client is connected to the server, okay? And then what it's going to do is it's going to request to read the characteristic value from this service of this server, right? So it's going to make a request. Hey, I'd like to see what your value is. When the client does that, when it requests to read the value of this characteristic, that is when this callback is going to be called. And so what we can do is we can update the value of the characteristic before this function returns, right? So we don't have to, like, I don't know, every 20 seconds we update this value. You know what I mean? Like, that'd just be wasting resources, I guess, right? If we had a sensor, say, we'd have to read from the sensor every so often, update it, yada yada. In this case, the only time we update the variable is when somebody's actually asking for it, which I really like. Okay, so what are we doing in here? Well, it's pretty straightforward. We're just getting the time of millis. So the millis function is going to return the amount of time the microcontroller's been running since it got turned on, since it got powered up, and I divide that by 1,000. So this will be basically like the number of seconds the microcontroller's been running, right? And I'm saving it to a variable called current millis, and the type I'm assigning it to is a 32-bit unsigned integer. Now you might know that a millis returns a long. Well, a long is 4 bits, same difference here, right? 32 bytes, 4 bits. So we're all good there. And then what we're going to do is pass current millis into the set value function of our P characteristic object. Now, this is where like all the cool stuff happens, right? This is like what you kind of like the end game is we want to be able to broadcast information like a sensor reading or, whatever, right? Like if you've got something you want to be able to send some information. And this set value function is where you're actually updating the information that's going to get, read or sent out when we do a notify, which we won't talk about now, but maybe later. Anyway, so this is where all the magic happens. Now notice I'm just able to put this in here, but what if you wanted to send like a character or something like that? Well, if you go ahead and dig into this set value function, you'll notice that there's all different types of stuff. There's all different ways to pass values into this little polymorphism going on here, right? So basically we could send a string, we could send a 16-bit unsigned integer, we could send a 32-bit unsigned integer, we could send a float, a double, like see all this stuff we could send. Okay, so now every time a client reads from our device, we should be able to pass the amount of time in seconds here, since we're dividing by 1,000, that the microcontroller's been running. Okay, let's go ahead and just click this off. So we created a characteristic, that's cool. We defined the characteristic UUID, we created a characteristic, we added the characteristic to the service, we created a characteristic callback, we did the whole subclassing thing, and we're sending the millis. Okay, wow, whew, that's a lot. All right, let me just do a quick recap of where we're at, because we've just been going over a lot of stuff, right? So we've got our BLE device include, we've got some defines at the top, our UUIDs that we've pulled in, and our device name. We've got our callback section where we've got our server callbacks for on connect and on disconnect. We've got our my characteristic callbacks that we just talked about, and we're overriding that on read function. And then in the setup, we've got our serial communication going on. We set our pin mode for that LED that turns on and off for our server callbacks. We initialize our device. We create a server. We add server callbacks to our server. Then we add a service to our server. Then we add a characteristic to our service. Then we add callbacks to our characteristic. We start the service, and then we start our advertising. Whew, that's a lot. Let me just do a quick recap of where we're at, because we've just been going over a lot of stuff, right? So we've got our BLE device include. We've got some defines at the top, our UUIDs that we've pulled in and our device name. We've got our callbacks section where we've got our server callbacks for on connect and on disconnect. We've got our my characteristic callbacks that we just talked about, and we're overriding that on read function. And then in the setup, we've got our serial communication going on. We set our pin mode for that LED that turns on and off for our server callbacks. We initialize our device. We create a server. We add server callbacks to our server. Then we add a service to our server. Then we add a characteristic to our service. Then we add callbacks to our characteristic. We start the service, and then we start our advertising. Whew, that's a lot. Well, hey, let's check the phone app and see if this is actually working. Hopefully I'm not getting ahead of myself here. All right, here we are in the light blue app, and we can see our CIA monitoring devices up here. Click on this. All right, nothing's changed there. I'm going to go ahead and click connect. Okay, cool. My LED comes on, and we can see here, here's the advertisement data. Again, nothing's really changed there. We see our service, and now look below the service. We see this new thing, this big long number here. Well, guess what? That matches up with our characteristic UUID, that 596 yada yada yada. Okay, so now what I'm going to do is I'm going to click on that, and now look at this. I've got this ability. I can write a value, but I can also read a value. All right. Well, this is cool. Let's go ahead and try reading a value. I'm going to click read. Now, you see this weird number? This is hexadecimal. Well, I don't know what it is with Bluetooth people. They freaking love hex numbers. Anyway, okay, so let me show you what I'm doing here. So in the top right, there's a little button that says hex. I'm just going to click on that. And now what I can do is I can select my format for the thing. So I'm going to say byte limit. I'm going to set it to 4. Okay. And then I'm going to select 4-byte unsigned integer, because that's what we're passing, right? So I'm selecting that. Now notice that the read value shows up as 146. Let me read again. Okay. See 185. So now let's count. So let's, okay. 1001, 1002, 1003. All right. Can you see that this is the number of seconds that my device has been running? Like, hey, that's how we're able to read information from our server, right? So our phone's acting as the client. This phone app is acting as the client, and we're reading from the server. And the server is also called a peripheral. Okay, great. Now notice that down in the descriptors it says no data, and I'll tell you what's a little kind of funky, right? When we look at this, I see CIA monitoring device. I like that. But this whole big number here above this, properties read write, that's not very descriptive. I wish there was some descriptor we could add to it to make it more readable. So why don't we do that? Let's jump into our code. And what we're going to do is add a descriptor to our characteristic. And again, a descriptor is like metadata for your characteristic. Like, is it in Fahrenheit? Is it in seconds? All that kind of stuff. So let's go ahead and do that, and we'll talk about it. All right, so here I am in the code, and I'm going to go ahead and add a descriptor for our characteristic. So what did I do in the code? Well, the first thing I did is I added another include, and I included this BLE 2901. Now, the reason I had to add this is for our descriptor. And if 2901 means nothing to you, well, it will mean nothing to you now, but not in the future. All right. So there are these predefined BLE descriptors, and there's this whole list of them. And they're like 2901, 2902, 2903, think of some reference manual, highly technical, that's got ye long list of numbers and some description about them. Well, that's what these descriptors are like. All right. So there is a descriptor called the name descriptor. I don't even know if that's the correct terminology for it. Anyway, it's called a 2901. It's a really common descriptor, and it's kind of been modeled in this BLE 2901 class right here. So if we just go into this, you can kind of get an idea. All right, so again, it's saying, hey, this is the GATT descriptor. So you remember what GATT was? Remember, you try to remember what it was and you feel like you're getting shot by a Gatling gun. Anyway, so this is descriptor 2901. It's called the characteristic user description. All right. And this is just a common descriptor that we can use to add. And basically what it does is it allows you to add user readable string describing the characteristic. Okay, so that's kind of what this does. And then all this in here basically just supports that. Okay, all right, so here we are back in the code. I added this, and in order to add that 2901 descriptor, we need to include this library. So I went ahead and did that. Then down here, going past our callbacks, here's setup. We're down into the setup. Here's our server, our services, our characteristics. Now here's our descriptor. So what I do is I create a pointer and I just name it Descriptor 2901. Again, you could name that whatever you wanted. Oh man, I didn't name it P though. I should have named it P. I'm going to change that right now just so that we're being consistent here. Do you want to supercharge what you know about Arduino? Start writing your own code instead of just cutting and pasting? Definitely check out programmingelectronics.com. We have a training program that's been designed to get you up to speed fast, writing your own code and building your own projects with Arduino. Check it out in the link below. That's programmingelectronics.com, and check out our training program there. All right, so we've got this pointer. We're setting it equal to the return from this BLE 2901, right? So this pointer right here is pointing to our descriptor. And then what we do is we say, all right, here's our descriptor pointer right here. We're going to call the set description function. And this is like the meat and potato of what this descriptor is. It's just a string that tells us, it adds some metadata to our characteristic. So I'm just saying, hey, time. So basically the value that you see, it's going to be called the time. And then the next step we need to do is we need to say, hey, peak characteristic, the one that we made up here, we're going to go ahead and add the descriptor. What descriptor are we going to add? Oh, hey, we'll add this P descriptor 2901 that we just, defined, all that kind of stuff right here. So hopefully that makes a little sense. All right, so what we did here is we created the descriptor, check, and then we added the descriptor. Okay, well, now let's go ahead, run to the phone app and see what that did. All right, so here I am in the light blue app. Here's our CIA monitoring device. I'm going to go ahead and click connect. All right, so now we're connected. And notice when we look at this, we see that instead of that big long characteristic UUID, we actually see the word time. So hey, that's pretty cool. Now it's a little more descriptive. We can click in there. Again, it's just like before. We can read values. I'm just going to go ahead. You got to set that every time. I wish there was a default where I could set it like that, but you can't. Anyway, so here I'm going to read the value. Okay, 94 seconds, 96, 97. All right, pretty cool. And here's the descriptor. What's it called? It's called time. Awesome. Well, this is great. So we've done a ton. Let's go ahead and jump back to the code and see what more we need to do to kind of wrap up this server example. All right, so we've been pretty busy. We created our device, we created the server, created our server callbacks, created a service, added that service to the server, created a characteristic, added that characteristic to the service, created some characteristic callbacks, or I guess just one callback, added that to our characteristic. Then we added a descriptor to our characteristic. Now all we've got left to do is some advertising. That should be easy, right? Well, it's not that it's not easy. It's just there's a lot to it. There's lots of layers to it. And that's what I think makes this BLE stuff so interesting. These layers aren't like necessarily complicating things. They're just a necessity for building really diverse and interesting things that you can do within this framework. So I think once you start to wrap your head around it, you build a couple BLE applications and stuff, it'll start, all starts to sink in a little bit. But okay, so here's this basic idea. If you recall, our device is what started the advertising. So we said BLE device start advertising. Okay, so this whole advertising thing is coming at the device level. And what we can do is we can actually define some of the advertisement data that we put out in the wild. And there's a couple different types of advertisement data that we can specify. We can say, hey, always kind of like show this stuff. And then we could say, well, only show this stuff if somebody's like asking for it or actively scanning for it. So there's some different stuff we can specify here. So it's basically, we can set advertisement data and then we can set like scan response data. Now, in order to handle the advertisement data, we've got these objects that we can use inside the library. And it's called BLE advertisement data. That's kind of the name of the data structure that we can use. And so what we're going to do now is we're going to just play around with some of the features of this BLE advertisement data, just to give you an idea of some of the stuff we can do with advertising. But we're really only going to touch kind of the tip of the iceberg here. But so what I'm going to do is go ahead and I'm going to write some code, and then we'll talk about it. All right, so what did we do in this code? All right, well, here I am down, here's setup, way back up here. Here I am down in this code, here's the descriptors, and here's the advertising. And I wrote a bunch of code, and I'll be honest, right now, this code doesn't do much. But I think in a later lesson when we talk about clients and scanning, some of this will make a little bit more sense. All right. So the first thing I did is I created a pointer. So we've got this P advertising as a pointer, right? And it is a pointer to a BLE advertising, this class right here. Okay. And I'm using the BLE device to get this advertising object. Okay. So my pointer is pointing to that object that's been created. So I make this, and I don't really do anything with it right yet. All right. I just kind of leave it up here. Then what I do is I create some advertisement data. Finally, we have something that's not a pointer. All right, so this BLE advertisement, again, it's a class. We're making an instance of that class, advertisement data, right here. And this advertisement object, it's got some functions. It's got set name, it's got set manufacturer data, it's got a bunch of different functions. In fact, why don't we take a quick peek and see the kind of stuff. All right, we've got set appearance, complete services, set flag, set manufacturer data, name, partial, like just see all this stuff, right? So you can set a bunch of different stuff. Here, I just set two things. I set the device name, and then I set the manufacturing data. You might be wondering, Mike, when we initialized our BLE device, didn't we already pass in the device name? Can't we already see the device name on our light blue app? The answer is yes, we can. But what I have found is that if you don't explicitly set the name here with the device name, not all scanners are going to be able to see that name. For example, when we make an ESP32 client, I find that just explicitly setting the name in the advertisement data helps the name to show up when you do a scan. Anyway, okay. Then I also set the manufacturing data. I just said, hey, Chinese factory. And again, this is just additional information that we can send when we're advertising. It's not required. You don't have to do this when a BLE device advertises. It's optional, but it's some additional stuff you can send. Then what I did is I made another BLE advertisement data object called scan response data. Notice that advertisement data and scan response data are both BLE advertisement data objects, right? They're made from the same class. Different instances of the same class. Okay, so we can do all the same stuff to this scan response thing that we can do to this advertisement data one. Do you want to supercharge what you know about Arduino? Start writing your own code instead of just cutting and pasting? Definitely check out ProgrammingElectronics.com. We have a training program that's been designed to get you up to speed fast, writing your own code and building your own projects with Arduino. Check it out in the link below. That's ProgrammingElectronics.com, and check out our training program there. Here, I'm also just setting the name, but I'm calling it this time extra scan data. Because if you'll recall, this scan response, what we're going to do is we're only going to pass this information during an active scan. So how do we set that up? All right, well, what we do is now we grab our P advertising object, that remember the pointer we made back up here with BLE device? All right, so we've got this P advertising object, and we're going to use this function called set advertisement data. So this is the data that our BLE object is going to basically put out into the world. And we pass it advertisement data, okay, which is this BLE advertisement data object. Okay, then what we do with our P advertising object is we use this set scan response function, and now we pass in our scan response data. Okay, so this information right here is only going to be sent to clients that are actively requesting it from a server. Now, the difference between this advertisement data and this scan response data is kind of nuanced, but here's the basic idea. A client can either be doing a passive scan or an active scan. If they're doing a passive scan, they're going to get access to this advertisement data. And this is really like the bare minimum stuff that you're going to get when you're kind of out there scanning for BLE servers. But you can also do an active scan as a client, and what that's going to do is it's going to query the server without connecting to it. So it won't actually connect to it. It's just going to send this little query, and it's going to get a little bit more information back. It's going to get the scan response data back. In our case, the additional information we send is just a name. It's going to say, hey, extra scan data. But again, there's different stuff you can set here. Okay, so we added our advertisement data and our scan response data. And finally, what we're going to do here is we're going to add our service UUID to this P advertising object. Now, it's actually already added by default. So we don't technically need this line of code. We'd be fine without this. Doesn't hurt to explicitly set it. And then what we do is we say set scan response true. And what that means is when somebody queries us for some scan response data, we will in fact send some data. Otherwise we wouldn't. All right, so let's go ahead and check out our phone app and see if this actually did anything. All right, so here we are in light blue. Here's our CIA monitoring device. And now I'm not even going to connect to this thing. And I want you to know that light blue, this app, is actively scanning. So it's not a passive scanner, it's actively scanning. It's sending out requests to get as much information from these BLE peripherals that are surrounding me. I have way too many, apparently. Anyway, so I'm just going to click this little arrow and let's see what we get here. Notice that down on local name, it says extra scan data. So that all of that stuff we did, that's pretty much all we're going to get out of that. The light blue isn't going to show the manufacturing data. You're not able to see that, but it does come in handy. Let's say when we build our own ESP32 client, we can query that information, find it, refer to it, display it, all that type of stuff. Okay, so yeah, everything else is pretty much the same. Again, no changes in here, but oh man, that seemed like a lot of advertising code for just one little line of text, but hey, what can I tell you? 'Tis life. All right, let's get back to the code and kind of wrap this up. All right, so what did we do? Well, we got that advertising object from the device. We created and set some advertisement data. Then we created and set some scan data. Then we added that advertisement and scan data to our advertising object. And then, we added that service UUID. And that was kind of it. Man, wow, this was a lot of stuff. If you stuck around this long, congratulations to you. I feel for you having to listen to me this long. But hey, if you like learning about this stuff, make sure to check out programmingelectronics.com. We've got a ton of training like this that can get you up to speed with Arduino, and it just can be a lot of fun. So definitely check out our program over there. Okay, so let's just do a once over one more time. All right, you ready for this? So for our server, again, what we were doing was creating a BLE server. The first thing we did is we created a device, and we initialized it. We gave it a name. And then we created a server, and that server gets created out of the device. Then what we did is we added some callback functions to our server, an onConnect and an onDisconnect. So when a client connects, an LED turns on. If a client disconnects, it turns off. We also ensured that we would start advertising again when a client disconnects. Then what we did is we created a service. We gave it a universally unique ID, and we assigned that service to our server, right? Actually, we told the server to create a service for itself. That's kind of how we did it. And then what we did was we said, hey, service, we want you to make us a characteristic. So we made our characteristic. Remember, the characteristics, like the meat and potatoes, it's like the actual data you want to transmit, right? So server is kind of a container for services. And a service is kind of a container for characteristics. And the characteristic is the actual values, the actual data that you want to communicate to other devices that might be querying your server. And then when we created this characteristic, we also made a characteristic callback, and we just sent the time. And we talked about, when we did these callbacks, we talked about how to subclass that callback class and, how to override those functions. All right, and then what we did is we added a descriptor, a common one, the 2901 descriptor, to our characteristic. And that was what just said, hey, this is time. It's a human readable description that we can add to a characteristic. Again, there's a ton of these different descriptors out there. Maybe we'll talk about them more in depth in some other lesson, but we're not going to talk about them now. But that's a pretty common one. And then finally, we talked about some of this advertising stuff. We set our advertisement data, which is going to be seen by any client just doing a passive scan. Then we set our scan data. That's going to be seen by clients that are doing an active scan. And we added our service UUID to our advertising object, and then we started advertising. All right, well, hey, that is a wrap. Whoa, if you made it this far, hopefully you've got an idea of how to build a BLE server. But guess what? This is only half the battle. We've only just begun. That's just our server. We actually need to make a client to, query the server. So, that's going to have to be the next thing we tackle. How can we make a client? What'd be cool? What if we make a client that is a scanner? What if we make a client that basically replaces that light blue app we were using? So we don't have to use a light blue. We can just use our client to sniff around for different Bluetooth devices. If you're working with the ESP32 BLE library with, the Arduino IDE, then one of the things you're going to really need to learn is how to create clients. So if you watch some of the previous lessons in this series, we talked about creating a server. Now we're going to talk about creating a client. So what I'm going to do is outline all the stuff that we're going to go over in this lesson. Now we are going to get nitty gritty. We're going to go line by line through the code. So this is going to be a pretty detailed technical lesson. But if your goal is to actually write code using the Arduino IDE to get BLE stuff to work, then you're in the right place. What I'll be doing specifically here is we're going to go over just the minimum stuff we need to get a client working. So let me write out all the stuff I want to do, and then we'll talk about it. Alright, so it's a big old list of stuff, but I think we'll be able to get through it pretty quick. So let's just walk through this real quick. So first thing we need to do is create a device. Now, if you remember kind of the outline, the design of this BLE library, you'll remember that we've got a device, and this is kind of the top of the hierarchy. And a device can make a server, or a device can make a client. So in this case, we're making a client, and we'll also be doing a scan. Okay, so back here we go. Okay, so we're gonna create our device just like we did when we worked on the server code. So it's gonna be just like that. Then we're gonna perform a BLE scan. You might think that a client does a scan, but actually it's at the device level that a scan is performed. And a scan is like its own thing, it's its own object and stuff, which we'll be talking about. Then what we'll be doing is adding some callbacks for our scan. So basically every time the scan finds a device, it's going to do something for us. Then we'll actually create our client. We'll create some client callbacks. I want to turn on an LED when we connect to a specific server, and then turn off just the onboard LED when we disconnect from the server. And then I want to actually connect to the server. So we'll have our client. We're going to say, hey, connect to a server. It's going to be a specific server. In fact, it's going to be the server that we previously created in lessons before this. So you'll want to check out those lessons if you haven't seen them yet. And then finally, what we're going to do is we're going to read the characteristic value that's on one of the services of that server. Specifically, we've got our server set up so that it reports the time and seconds that it's been running. So I just want to be able to read that value on my client. So my server is basically advertising that, and we're going to pick it up in this client and read it. All right, so I think where I'm going to start is with creating this device. So let me write some code and we'll talk about it. Alright, so I wrote a little code. Let's talk about this. So the first thing I did is I included this BLE device library. And if you didn't know, when you include a library, that gives you all the functionality from that library. Like that's how you pull in all the capabilities. And that's what's so amazing about Arduino is there's tons of open source libraries out there. So it's great to be able to pull those in instead of having to write all that stuff from scratch. So a big shout out to all those awesome open source developers out there who are making this stuff available. This BLE device library, like I've mentioned in a previous lesson when we were talking about the client, it actually includes other header files in it, like the BLE client header file and a couple other ones. In fact, we can just go check it out. Go to the definition here. Okay, you can see that this header file also includes the server, the client utils, scan, and the address. So we don't need to, we'll be using a client, we'll be using the scan, but we don't have to include those separately because they're already here. Why add it? Okay, so then what I did in setup is I started serial communication, pretty common thing to do. And if you're not familiar with like serial communication, or if like right now you're kind of like, man, I don't know what's going on, definitely check out programmingelectronics.com. We have got some great training there that can get you up to speed fast with programming with Arduino and building cool projects and stuff like that. Okay, final thing I did here in setup is I initialized our BLE device. Now, if you're looking at this syntax wondering like, what the heck is going on? Trust me, you're not alone. So basically what's going on here is BLE device is a class, and BLE device doesn't want you to make a bunch of instances of BLE devices. We can only have one BLE device in a given sketch. So maybe you've worked with other classes, other libraries like, say, the servo library. Well, you can create several instances of a servo. You can have like servo 1, servo 2, servo 3. Well, that's not the case for BLE devices. You can only make one BLE device. And what it does is it sets up the whole BLE stack. And so this init function is what's called a static function of this library, of this class. And so when we initialize this, we're not creating like a unique BLE device per se. We're just creating the BLE device that we're going to be able to use throughout the program. Now, I don't know, maybe that's clear as mud, but just trying to explain it as best I can. Anyhow, when you're using a static function that's part of a class, you use this : to reference it. Because you might be thinking, wait, if init is a function of this class, why wouldn't it be BLE device.init? Right? Just like serial.begin. Begin is a function of the serial library. But again, the reason is because init is a static function in this library. And that's why you use that : Okay, clear as mud, I'm sure. Now, the parameter that we pass into init is normally the name of the device. And when we created the server, we passed in a name. It was like CIA monitoring device or something like that. Well, when you're creating a client, you don't really need to add a device name because nobody's going to be looking for your client. The client's the one looking for other people. So there's really no need to pass in a name. So I just added those empty quotes. Okay, so let's go ahead and look at our to-do list to see what we did here. All right, so we included that BLE device library and we initialized the device, and that's basically created our device. All right, so now what I'm going to do is go ahead and work on this BLE scanning so that we can search for BLE devices out there that are advertising. So let me go ahead and do that. All right, so I wrote 3 lines of code here, and these are what's setting up our scan. But before we talk about this code, I want to talk a little bit about the scan just graphically, because I think this graphical representation can help us out a little bit. Okay, so what I want to do is I just want to remind you that a device is what starts a scan, and a scan is an object that we can use when we want to perform a scan. So, like a scan, the word scan, it's like a verb, right? You would think like, oh, hey, this is, doing the scan when I call this scan function, right? Well, we're actually going to first create a scan object. And then once we have that scan object, That's how we can perform a scan. And we can set attributes for the scan, like how we want it to do the scan and that kind of thing. But again, this scan comes from the device level. You might think like, hey, I'm a client, I'm going to do a scan. Yes, that's very typical, but the scan isn't attached to the client. The scan is actually a part of the device. Now, what's also important to note is that you can only get one scan object in a sketch. So just like with the device, there's only one device, well, there's only one scan. Okay, so we talked about what this scan object is. Let's look at how we actually create a scan in the code. And that's this first line of code right here. We are going to call our BLE device class, and we are going to get our scan object. Notice that we're using this : and if you recall, that's because getScan is a static function of this BLE device class. So we're not getting a unique scan object, we're getting the scan object from this BLE device class. Okay, now this getScan is going to return a pointer to a BLE scan. That's the type of object it is, a BLE scan. And so what we did is we created a variable pBLEScan. It's a pointer to the BLE scan object. So when we want to work with our scan, we use this pointer pBLEScan. And the P in front of the BLE scan is just saying, hey, this is a variable that's a pointer. And if you didn't know, a pointer is simply a variable that holds the address of another variable. Now, if that means absolutely nothing to you, that's totally fine. Check out programmingelectronics.com. We've got a training course specifically on understanding and using pointers. Hopefully it can provide you some clarity. But this BLE library is full of pointers, so you want to try to get a little comfortable with how they work. Okay, so now we've got our scan. Now what we want to do is we want to say, hey, scan, we want you to be an active scan. And that's what we do on this next line of code. So you might be wondering like, hey, what's an active scan? Well, let's go back to this little diagram here, and I've got another page here. All right, so let's check out this diagram here. Hopefully this will help explain some of this active and passive scanning. All right, so in BLE, we can perform a scan. So we know that we can scan for stuff, right? And we can either perform an active or a passive scan. So what does that mean? Well, if you're a device that is advertising different services, then you can have advertising data associated with your device. And there's two different types of advertising data that you can have. You can have passive advertising data, and you can have active advertising data. In fact, you can have both. You can have passive and active. Now, if you only have passive advertising, what it means is that when a client does a scan, a passive scan, you're going to send it some basic information, like maybe your name and address. And that's it. You don't have any more information you're going to send about your services, just some really basic stuff. And it's not going to require, when you do this advertising, it doesn't require a client to connect in order to send that information. All you have to do is perform a scan, and you can grab this information. Real basic stuff, right? But there's some additional advertisement data that you can set as active. And this advertisement data might just be some more details about the services you offer. But you're only going to send this information out, this other active data, if the scan is performing an active scan. So if I'm performing the scan, let's say this is a client performing a scan and this is a server advertising services. If I perform a passive scan, all I'm going to get is this passive information. Again, no connection required between these two devices. Now, if I do an active scan, I'm going to get this passive data, and then I'm going to call back again, and I'm going to get this active data. I'm doing an active scan, so I'm going to get both of these. And this also, to do an active scan, does not require a connection. So my client does not need to be connected to the server in order to make this active scan happen. Now, you might be like, man, this seems a little redundant. Why don't you just fit all this active stuff into the passive stuff, just make it one thingamabob, right? Well, here's the deal. It's all in the name. Bluetooth Low Energy. Every time you perform a scan, it requires power. And every time you're a device and you're sending more information, requires power, right? So if you're being super power conscious, you don't want to have these active scans on. You just want to keep it passive. Okay, hopefully that made a little bit of sense. I don't know. So let's go back to our code here. This next line of code right here, BLE scan set active scan, is basically saying, hey, we want our device to do an active scan. So it's going to get the passive data, and then it's going to perform an active scan. And if the device has any additional information about the services it provides, it's going to get that information too. Now, notice this little arrow right here, you might be wondering like, hey, what's the deal with this arrow? Well, setActiveScan is a function of this BLE scan object, right? But since BLE scan here, we're working with a pointer. In order to access those functions, those member functions, you don't use the dot operator, you use this little arrow. So that's what's going on there. Now this final line of code is where we actually start the scan. So here's our scan object. We say, hey, start, and 5 represents the number of seconds that it's going to perform the scan. And then the second argument we send is false. And this is whether or not we want it to be a continuous scan. So do we want it to scan for 5 seconds, stop, and then do the scan again, stop, do the scan again, going. If we wanted that to be the case, we'd set that to true. But we just want it to run this scan 5 seconds and be done with it. In fact, you can even run this function without this second argument. You can run it just like this, but we're just going to keep it in there. So man, that's a lot. I know this is a lot. Hopefully you're hanging in there with me. Okay, so what did we do? We performed our BLE scan. The next thing I'm going to do is write some callbacks for the scan. Because right now, okay, hey, we're performing a scan, but like nothing's happening. I want something to happen, right? So what we're going to do is create an advertised device callback. So every time we find a device, we're going to do something. So I'll write some code and then we'll talk about it. All right, so I added a couple lines of code, which we'll be talking about now. And I also adjusted the font size. I made it a little bit bigger because I really want to try to focus in on these lines. If it's too big, let me know in the comments. Maybe we can adjust for future videos. But all right, here goes. So first thing I did is I added this line of code down here right after we created our BLE scan object, after we grabbed it from the BLE device. And what this line does is it sets the advertised device callbacks for our scan. Now, a callback is simply something, usually it's a function, that gets executed every time a specific thing, like some event happens. And in this case, these callbacks are for advertised devices, and they're part of our scan. And so the event that will trigger these callbacks is as you're performing the scan, when it identifies a device that is advertising. That is, it's going to execute this callback. So it's scanning, maybe it finds a device. Oh, hey, execute this callback. It keeps scanning, finds another device. Hey, execute those callbacks again. And every time the callback gets executed, information about that advertised device, the advertising information, remember we were talking about the passive and active stuff, that advertising data, that's going to be available to us in our callback. So now let's go ahead and just take a look at the callback specifically. Okay, so here it is right here, and the syntax is a little intimidating. I know we talked about callbacks previously in the lessons when we were talking about client, so I'm really not going to go into it too much, but basically this BLE advertised callback is a virtual function in our BLE device library. And what that means is we're able to overwrite it, and we're able to overwrite the functions inside of that class, which in this case are onResult. So basically, what it allows us to do is say, hey, when we find a device, this is what we want to do. We're going to tell you what we want to do. All we have to do is follow the specific functions and the parameters they set for us. For example, the function inside our callback needs to be named onResult, and it needs to take a BLE advertised device as the parameter, and it's going to return void. So I know that's probably clear as mud. Hopefully, we talked about it a bit more in the client lessons. Hopefully that kind of carries over. If not, you can review those. Okay, so when we find a device, what do? Well, what we're going to do is just print off information about that advertised device. And a really easy way to do that is to use this toString function that's part of an advertised device. Now, an advertised device is like another object in this library. It's got its own functions and data associated with it. And if you haven't noticed, there's all types of classes inside this library, and it can get really confusing at times. And so what's really helped me think about and explore these different classes is to look at the source code for this BLE library. So I'll link to this. This is the supported library by Espressif for the Arduino ESP32 library that we're working with here. And you can see all these files right here. This is all the source code, right? So far, we've been working with the BLE device and the BLE client. That's what we're working with now, but the BLE server's in here, and we've got advertising. We were just talking about advertising, but here's this BLE advertised device. So if you look at the source code, you can see the different functions and data associated with it, right? So if you're wondering, hey, what can I do with a BLE advertised device? Well, you can come to the source code, take a look, and look at the different functions associated with it. I don't know. That's what I've been doing a lot. It's been super helpful for me. But that's how I learned, like, okay, hey, this object has a toString function, because I just looked at the documentation, and you come through here, and down here it says toString, and it returns a string. So what this is going to do is take some of the data associated with the advertised device, turn it into a string so that you can print it to the serial monitor. Okay, so what I'm going to do is open up our serial monitor, and I'm going to reset our ESP32. I've already uploaded this code, and then we'll see what shows up on the serial monitor here. Okay, so we print off BLE advertised device. Ooh, fount instead of found. Okay, found. Well, fount. We found it. All right, anyway. So what this prints off is the name, right? And looks like we found, I have that other server running. We called it the CIA monitoring device. It gives us the address. It gives us the service UID, the power, and then the RSSI, which is like the signal strength. So you can see it did it for, let's see, 1, 2, 3, 4, 5, 6 different devices is what it found in my office here. And it looks like only one other one had a name called mesh device, but you can see you're going to get the address of all of them. Some of them had manufacturing data, but that's what this device callback's doing. We could do something totally different in here. Maybe we want to blink an LED every time we connect to a device. Maybe you want to sound a piezo buzzer every time you find a device. That's actually a lot of fun. You get it to beep in interesting ways. You can do whatever you want, but in our case, this is what we're doing for starters. Okay, so we've created the device callback. Hopefully that was helpful. All right, so we created that, great, and then we printed off the device info. So now what we're going to do is we're actually going to create our client, and then we're going to create some client callbacks. And I think what I'm also going to do is set our target service and target UUID. So let me do that, and then we'll talk about it. Okay, so I wrote some code for creating our client. So if you recall, the first thing we did is we created a device. We initialized our device. Then we did our scan and performed a scan, set it active, started it, all that great stuff. And now we're actually creating our client. And our client is what's going to connect to a server, get information about that server. So this first line of code right here that we added for the client, notice it's a lot like getting the scan, right? In this case, though, we're creating a client. It's going to return a pointer, so we save it into a BLE client pointer variable. All right, so we've got our client. It's named pClient. Then what we do is we are going to set some callbacks for our client. Same way we did with the My Advertised Devices, but the client callbacks give us some different functions. Let's go ahead and look at the My Client callbacks. Again, the syntax is pretty much the exact same as before. We're making a class. We're overwriting that BLE Client Callbacks virtual class. And now the two functions that we can write are onConnect and onDisconnect. So what this means is that anytime our client connects to a server, then this function right here, onConnect, is going to get executed. And every time our client disconnects from a server, it's going to run this code right here, this onDisconnect. And all I'm doing is printing some stuff off. I turn on an LED when we're connected, and I turn off an LED when we're not connected. So again, callbacks, they get executed when an event happens. And in this case, it's the client events, and those two client events that we're interested in here are the on connect and the on disconnect. Okay, but what we haven't done is actually connected our client to a server. So we scanned for devices, we created our client, but now we have to say, hey client, we want you to connect to a specific server. Now the way we're going to do it in this program, again, this program, I'm trying to show you the very basics of this client, how to connect to stuff. Now the way we are going to connect to a device is by actually hard coding the service UUID that we're looking for. Now in a previous lesson, like I mentioned, we were working with ESP32 servers. And so for that server, we created a service that had a specific UUID. That's like the ID associated with that service on that device. And so what we're going to do in our code is every time in our advertised device callback, we're going to check if the device we found advertises that specific UUID. And if it does, we're going to say, hey, this is the device we want to connect to, and then we'll go ahead and connect to that device. So let me write some code and then we'll talk about it. Hopefully it'll make it a little bit more clear. So I wrote quite a bit of code here. We're going to talk about it. And just remember, like, it's okay if it, this gets a little bit confusing. This is all part of it. But the payoff, learning how to use this BLE stuff, there's a huge payoff because you can make a lot of interesting stuff with it. Okay, so there's my disclaimer. I'm going to do my best to help explain this. But it's a little technical. Sometimes I trip over myself. But anyway, okay, so let me start at the top here. First, what I did is I added 3 global variables. The first is our target UUID service, and then the other one is our target UUID characteristic. So I pulled these values from the server sketch. So it's around here somewhere. Here we go. Here's the server sketch that we worked on, and here's the UUIDs for the service and the characteristic that we defined. We said, hey, this is what this service is going to advertise. And now what we're doing in our client is we're saying, hey, this is the service I'm looking for. This is what I want to learn about. I want to read that information. Notice that the type here is BLE UUID, right? We didn't just save this as a string. This is the name of the variable. We pass in the string data and we get our BLE UUID. So now we can refer to this and the type is this BLE UUID. And a lot of the functions in the library require you to pass in this type of object. Okay, so we created this. Notice that I made these static. Now, I'm going to be perfectly honest with you. If it was me, I wouldn't have made these static. But in all the example code that comes with the BLE library, when they create clients, they make the BLE UUIDs static. The reason I think they're doing it is because they don't want there to be some type of naming issues going on with other files sharing that same, like service UUID kind of thing. But anyway, I'm just going to stick with what they had. All right, the third global variable I made is a BLE advertised device. It's a pointer target device. And we made this a pointer, so I should put a P in front of that. Let me rename that symbol. All right, so we're just going to have to manually do it. All right, so there's P target device. Okay, just trying to remain consistent here. So target device is a pointer, and it points to type BLE advertised device. Now, if you'll recall, in our my advertised device callback, so remember when we perform a scan, this is the callback that's going to get executed when a new device is found that's advertising. And what we get for that advertised device is a BLE advertised device. So, okay, so notice how these match. All right. So what we're going to do now in our advertised device callbacks is we are going to run a check, and we're going to say, hey, this advertised device I just found. We're going to say, hey, do you have a service UUID? We just want to make sure it even has one, right? We're going to say, yeah, do you have one? Okay, let's say it has one. Good. Then we want to say, hey, are you advertising this specific service? And the service we're interested in is this one right here. We're saying this is what we're on the lookout for. So again, every time we scan for something, we're going to ask that device. We're going to say, hey, are you the service we're looking for? And if it is the service we're looking for, what we're going to do is create a new BLE advertised device using the information from this advertised device that we have access to when we perform the scan, on this callback. And we're going to save that to P target device. Now, I know that seems a little odd, right? I know, a little bit confusing. Let me try to say that again. All right, so this callback gets called every time a new device that's advertising is identified. All right, what information do we have available inside this callback? Well, in this onResult function in here, we have access to the advertised device data, right? So this is going to be like any information it might be advertising. Maybe its address, its name, manufacturer data, all that type of stuff, right? So we have access to that specific device's advertising data. Okay. And then what we're going to do is we're going to look at that specific device and we're going to say, hey, are you the one we're looking for? Because we know which one we're looking for. Are you the one we're looking for? And if it is, then what we're going to do is we're going to take all that device, we're going to take it, and we're going to create a new object and save it. We're going to save all that information. We're going to save its address, its service UUID, anything that it provides. We're going to save it into our own little global variable here called P target device, right? That we made up here because it's a BLE advertised device. And notice we're using the new operator here when we create this. And the reason is this advertised device right here in this function, its life is going to be gone after this function ends, right? So advertised device is just local to this function right here. And if we just set P target device equal to advertised device or a pointer to advertised device, whatever, right? Well, then our pointer would be pointing to something that didn't exist after this function exited, right? So we actually have to make a new instance of a BLE advertised device, and we're going to use this advertised device to make it. So I don't know if that made any sense or not. I hope it makes a little bit sense, but the bottom line is we are grabbing the device that matches the service UUID that we're looking for. We're going to grab that device information. Okay, so that's what we do in this callback. So now we've got that device information, and now what we can do when we come down to setup is we can actually connect to that target device. So we're just going to pass in that device. And when we pass in a device to the connect function, it's going to find the address that's associated with that device for the target device, and it's going to connect to it. And then what we do is we just print off, hey, we're connected to, and then again, we've got access to this target device so we can get the name. We're just going to go ahead and print off the name. Now, I want to make a quick note. Actually, I want to make a couple notes here. I'm not being super safe in a lot of cases here. Okay, and the reason I'm not being super safe is because there's just a lot of code that goes into being like guarded, being smart when you're doing this, basically. Okay, so what am I talking about? So before we ask to get the name of this target device, first we should check, does it have a name? Because it might not have a name. So what we ought to do, if we were smart, is we would say, hey, target device, do you have a name? So we check, hey, do you have a name? And then if it has a name, then we would ask to get the name. Because if we ask for a name and there's no name there, because what we do then is set ourselves up to reference things that don't even exist, our program's going to crash and it's going to suck. But the reason that doesn't matter in this case is because we know our server's running, we know that it has a name, and so when we call this, we're not going to get an error. Hopefully that made a little sense. Maybe it didn't, but okay. The other thing I wanted to note was that this scan, the start scan function, it's blocking. So for 5 seconds, this whole program is going to stop, and it's all it's going to do is scan. And once the scan has finished, then the rest of the code is going to execute. And that's important because we're making reference to this P target device, which is nothing until this scan is done, right? This is not referencing anything until the scan's finished and we found the device. Now, again, here we're saying, hey, go ahead and connect to P target device. But what if I don't know, what if our server was turned off and we never identified a device to attach to, right? Or to connect to, right? So this P target device would just be uninitialized. Well, then again, our program would be crashing because we'd be trying to connect to something that doesn't even exist. So before this connect call, you might want to check, hey, is P target device not null? And then once you're sure it's not null, then you go ahead and connect to it. Anyway, again, I'm leaving some of those guards out because I want to try to keep the code a little bit more concise, but I don't know. So now that we have got this code written, I'm going to go ahead and open up the serial monitor window. Okay, and what I'm going to do is press the reset button on my ESP32 board that's acting as a client. Okay, so I just reset it. Okay, so now we've got all our scan information, right? This is all that scan we just did. And then it says, hey, look, target service found. So we found that service we were looking for. And then it says BLE advertised device found, right? So this is, again, we're performing our scan. Then we get to the CIA monitoring device and it says, yep, hey, that was the target service. Now it continues the scan, finds one other device, but then we show that we're connected and it says we connected to the CIA monitoring device. And if you look at both of my ESP32s, the one acting as the server and the one acting as the client, the LED has turned on. And the reason it turned on the client is because this onConnect function was called. Hey, when I connect, go ahead and turn that onboard LED. So the LED is on. I had code in the server that also turned on when a client connected to the server. So that's pretty cool. So let's go up here and we created our client. Nice. We created the client callbacks. We turn on an LED. When it's connected to the server, we turn off the LED. I set the pin mode. We connected to the server. Man, okay, so all we've got left to do is read the characteristic values from our target service and characteristic. Okay, and you know what? We actually already set these. I guess I jumped ahead. I didn't need to set the target characteristic, but I already did. Okay, so now we just want to read the value from the target service. Like, hey, it's cool to connect to servers and stuff, but I mean, what we really want to do is read information, right? We're trying to build some interesting information sharing network here. So what I'm going to do now is I'm going to set it up so that we can read the value that our service is advertising. And if you'll recall, the server's advertising how much time in seconds that it has been running. Okay, so I'm going to do that and then we'll talk about it. Okay, so what we want to do is show the value of a characteristic. Now, if you recall, if we go back to our little chart here, and let's see if we can, okay, if you recall, we've got a server, right, that's running on a separate ESP32. That server is running a service. And actually, let me go to another one. Here we go. This makes a little bit of sense. See how a server can have multiple services? And then each service can have multiple characteristics with it, right? And so when we try to get a characteristic from a server, what we need to do is first identify which service it is that we're talking about. And then once we've got a handle on that service, we need to say, hey, which characteristic in that service? Okay, so we're clear on that. So first we need to get the service from that server, which one? There might only be one, but you still need to say which one you want. And then you need to grab the characteristic of interest from that service. Again, there might only be one, but you got to say which one it is. Okay, so if we come back to our code, you'll remember at the very top we said, hey, this is the service UUID target. This is the service we're interested in. And this is the characteristic target we're interested in. Okay, so now what we do down in the setup, after we created our device, we created our scan, we performed a scan. During the callback in the scan, we identified that target device that we are interested based on, hey, is this the service? Are you advertising this service? So we know which device is advertising the service we want. Okay, we did that. Then we created our client and we said, hey, that one device, the one that's advertising that service, yeah, we want to connect to that one. So we connected to that device. And now what we want to do is we want to get a characteristic from one of the services on that device. So the first thing we do is we're calling pClient and we say, hey, we want to get this service. Which service do we want to get? Hey, it's that target one that we just talked about before. So we grab this service, and this is going to return information about that service, and it's going to store it in a pointer to a BLE remote service object. Okay, so this remote service. So you've got services, but then when you're on the client side, we're going to talk about remote service. So a remote service is just talking about the service that's running on some server that we've got some information about. Okay, so basically our remote service, we've got information about it. We just grabbed it from this get service function that's part of the client. Okay. Hopefully that made a little sense. Then what we do is we say, now that we've got that remote service, now we're going to go into the remote service and we're going to say, hey, remote service, you got some functions too. What can you do? Well, a remote service can get characteristics, and specifically it can get a specific characteristic, and that's why we pass in the characteristic UUID that we were interested in. So we say remote service, we want to get a characteristic, and this is it. And then we're going to save that to, guess what, a BLE remote characteristic pointer. So now we've got a handle on a remote characteristic. We got information about it, right? And so now that we've got that characteristic, now what we can do is read the value of the characteristic. And here I'm using the function, it's read unsigned integer 32. Now the reason I'm using this one is because in our server code, we are writing a 32-bit integer as the characteristic data. And that's why I'm using this read uint 32. Now the reason I know that this function exists is because, again, I'm always checking out this source code. So if I go to source here and we're looking at BLE remote, so I'm just going to come down to the remote characteristic.h. So this is a source code for the BLE remote characteristic.h. And if I come down here, here's the class, here's the public. So this public stuff, this is all the stuff that we can use. These are our cool functions that we get for free. I love it. And notice that down here we've got, let's see, read int8, read int16, read float. We also have just read value, which is a string. But again, in our server, our characteristic, it was a 32-bit integer, and so that's why I'm using this read uint32. Hopefully that makes a little bit of sense. Maybe not. Okay, so now we read the value and I save it to a variable named value, which is an integer, and then I just print it off to the screen. Like, that's literally it. So what I'm going to do now is open up the serial monitor window, and I'm going to press the reset button on my ESP32 that's acting as the client. Again, I've already got that server running. It's been running for a while. Okay, so we should perform the scan. So right now that scan is taking place. Remember, scan is a blocking function. Oh, it looks like it found our target device. That's great. Okay, again, we were looking for the CAA monitoring device. And now it says, hey, I connected to CAA monitoring device. The characteristic value was 11,504. So that is the amount of time that the server has been running in seconds. So here's what I'm going to do just to demo this. I'm going to go ahead and reset the ESP32 that's running the server, and then I'll reset this client and see, it should be a smaller number, right? Because it will have just been running. Let me do that. Okay, it's doing the scan. Let's see if it finds our... Okay, look at that. Now it's only been running 8 seconds. So you can see we're getting the value. Okay, hey, this is pretty cool. I mean, this is like the whole idea, right? Now we've got a client and a server running. Now here's the thing.
Danger, Will Robinson. Danger.
I cheated painfully. I cheated so bad right here. And when I say cheat, I did something that is not smart. It's lazy as all get out, and it's only going to get you into trouble. Remember before I was talking about adding guards to make sure that something exists before you try to get it and there's nothing there? This will just crash your code in a heartbeat. The only reason it's working right now is because I know my server's running, right? But you can't depend on that. So I'm just going to give you an example of what a guard would look like. And after every single one of these lines of code, you should be running one of these guards that I'm talking about. So anytime you're trying to get a service, you should always be checking if you actually got that service. Because if you didn't, it's going to be a null pointer, and then you're going to be making references to nothing. All right, so let me just code an example here real quick. Okay, so I wrote some guards. I know I said I was only going to do one, but I just wanted to kind of show you what I'm doing here. So basically, up here where we get the service. Remember, we're saying, hey, client, you connected to a device and we want you to get the service, this service right here from that device. Okay, so we're assuming that that service exists. Well, what happens if it doesn't exist? Well, this returns a null pointer, get service does. And so all we do is we check, hey, is our pointer here, is it a null pointer? If it is a null pointer, we want to disconnect because we don't want to try to reference a null pointer down here when we're trying to get a characteristic from that service. So we're just making sure that we're not, again, trying to reference a null pointer. All right, then here we do the same thing with our remote characteristic. We're saying, hey, service, go ahead, I want you to grab that characteristic, this specific one. Well, if this specific one doesn't exist on that service, then this will return a null pointer and we can check for that. And if it's a null pointer, we say, hey, no, sorry, this is not the one. Let's go ahead and disconnect from the client. And then finally, when we do have a characteristic, if we make it this far, we need to make sure that we can actually read that characteristic. Not all characteristics have read permissions. Maybe it only has write positions. It might have read and write, but you need to check that before you try to read it. So here we're saying, hey, can we read this device? And if we can, that's when we go ahead and read the value from that characteristic. So you can see this is quite a bit more code. I mean, we had 3 lines of code before, right? Just this one, and like this one right here. 3 lines of code, it kind of blows up into maybe 20 lines of code right here. But these are the 20 lines of code that is going to make your program more robust. So when you're actually, using this stuff in the wild, make sure to have these guards in there. Okay, so let's go ahead and go up to our to-do list and see if we knocked everything off. All right, we're reading a characteristic value. Man, that feels good. Wow. Okay, if you're still hanging around, that means you are invested in this, means that you are hopefully understanding a bit more about all this BLE ESP32 stuff. And I tell you, there's a lot going on. Thanks so much for coming on this journey with me. I hope you've learned a ton. If you have questions, just leave them in the comments. I'll do my best to help talk about stuff. I apologize ahead of time if I've made any errors in this series. I'm sure I did. Sometimes I trip over what I'm trying to say, but I definitely did my best. So definitely check out programmingelectronics.com. We have got some great training there that can get you up to speed fast with programming with Arduino and building cool projects and stuff like that.